I'm going to attempt to do now is some problems on the PowerPoint. So after slide 11, there is a PowerPoint slide with a list of some problems doing gram, mole, and particle conversions. So I'm going to start with the first one on that PowerPoint slide, which is 25 grams of CO2, and we are going to convert that to molecules of CO2. All right, so if you've noticed from the flow chart on the PowerPoints, we can't go directly from grams to molecules. We have to go to moles first. So I'm going to write over in the corner here kind of my plan. So I'm going to go from grams of CO2, and then I'm going to go to moles. And then, once I'm at moles, I can go to molecules. So what do I need for these steps? So when I'm going from grams to moles, I'm going to need the molar mass of CO2. So that's what that MM stands for. My next step, once I'm at moles and I'm going to molecules, I will need Avogadro's number to solve that. So over here in the corner, I am going to calculate my molar mass of CO2. And remember, to calculate molar mass, we make a list of every element present, carbon and oxygen in this case. We then write how many atoms of each element are present. So these numbers here I just simply got from the subscripts. So carbon, no subscripts, so just one atom, oxygen, 2. I then look up their molar masses on the periodic table. So carbon is 12.01. And oxygen is 16.00. So multiplying and across and adding those two together, so let me do that calculation quickly. We get 2 times 16, it's just 32 plus 12.01. So we get a total molar mass of 44.01, and remember the units are grams per mole. So I'm going to write that out like a conversion factor. So 44.01 grams is equal to 1 mole. And if you hear any noises in the background, I am stuck home here with my kids, much like many of you, so you'll hear some background noise and maybe some interruptions from time to time, so just bear with me. All right, so I have the molar mass written here. 44.01 grams is equal to 1 mole. That will be one of my conversion factors you'll notice that I'm using in my first step. Okay? Before I start my railroad tracks, though, I'm going to write down Avogadro's number as well, since I also need that. So Avogadro's number is 1 mole is equal to 6.022 times 10 to the 23rd. And notice entities is written after this. Okay, so what I'm going to go look at now is what type of molecule I have. Do I have a covalent compound, an ionic compound, or do I have an element? So I have 2 nonmetals, carbon and oxygen, so it's a covalent compound. So what I'm going to write after this 6.022 times 10 to the 23rd is the word molecules. Okay, and I mean it's already given to us here, but I wanted to explain why they chose the word molecules instead of atoms or formula units. Okay, so I have my 2 conversion factors, molar mass, Avogadro's number. Now I can start my railroad tracks. So it's going to be a long one. Let's start here. So remember, what always goes in this upper left-hand corner is what you want to start with. In this case, it's going to be 25 grams of CO2, what the problem is asking, what the problem gave us, I should say. Now next, I'm going to take that molar mass right here, and I'm going to plug it in so that I'm canceling out the grams and I'm getting the moles. So I'm putting this 44.01 grams on the bottom, and on top I am going to put 1 mole. So grams of CO2 are now canceling. Now I'm at moles. I'm here. Okay, so I have one more step to get all the way to molecules, and that is using Avogadro's number. All right, so this conversion factor I will put on my railroad tracks next. Now, what do I want on the top? Do I want the moles on the top, or do I want the molecules on the top? Okay, and what we're going to need, right, is the molecules on the top. So that Avogadro's number, 6.022 times 10 to the 23rd, is going to go on the top. And then that will put my 1 mole on the bottom, so that the moles and moles are on opposite sides of this horizontal line, thus canceling each other out. Okay, so I'm going to enter this all into my calculator. Remember, when you're entering Avogadro's number, to use that EE button. So I'm taking 25 multiplied by 6.022 times 10 to the 23rd, and I'm going to divide all of that by 44.01. So what I get out is 3.42. Let's see. How many significant figures do I have? So going back to your original number, there are 2 sig figs here. So I am going to report 2 sig figs in my answer. So I'm going to stop at that 3.4. So 3.4 times 10 to the 23rd. So don't forget that times 10 to the 23rd. That's important. And my units are molecules because I am talking about, a covalent compound. All right. So that is the first problem on the PowerPoint. So I'm going to go ahead and erase this, and we're going to try the second problem on the PowerPoints. Sure, everything is kind of still in line here. All right. So kind of have a jimmy-rigged system, so hopefully this is showing up all right. So I got 3.6 times 10 to the 24th. And we have atoms of sodium, and we are going to go to grams of sodium. Okay, so let's look at this. Can we go directly from atoms to grams? We cannot. So what we have to do is we have to go to moles first. Okay, moles is our middle ground. So I'm going to draw a quick outline here. I'm going to go from atoms to moles, and then once I'm in moles, I can get to the grams needed, asked for in the question. All right, so now when I'm at atoms and I want to go to moles, what do I need? What's going to help me convert from atoms to moles? Avogadro's number. Okay. Now, to go between moles and grams, what do I need? What I need is molar mass, because remember, molar mass, the units on it are grams per mole. So that's going to help us get between those two. All right, so I'm going to write over in the corner here my molar mass of sodium. So this time it's just an element. That's why we're using the word atoms. And I don't have to do any calculations. I just have to look up sodium on the periodic table, which for some reason I don't have out. And then I also want to write down Avogadro's number. So let's see, sodium is 22.9. Grams, 1 mole. Okay, and then Avogadro's number, of course, 1 mole is equal to 6.022 times 10 to the 23rd, and this time it's atoms, since we are talking about an element. So those are our conversion factors. All right, so let's start our railroad tracks. When we start our railroad tracks, we start with what is given in the problem. Running out of room. It's atoms. Okay. So we're at atoms. Our first step shows that we want to get to moles, because we need to be in moles in order to get to grams. So this first step, I'm using Avogadro's number. do I want atoms on top or atoms on the bottom? I want atoms on the bottom so that it cancels. Atoms, atoms. So after doing this calculation, this division, I will be in moles. So my next step then is to go to grams using the molar mass. So the molar mass, now do I want grams on top or grams on the bottom? You always want to put what you're looking for on the top. So it's the grams that we want to keep, so I'm putting that on the top. And then the 1 mole is going to go on the bottom because that's what I'm trying to get rid of. Okay, so to do this calculation, if you're getting the wrong answer, make sure that you are correctly putting in your powers. So I got 22.99. Divide that by, oftentimes you might need to put Avogadro's number in parentheses. So that 6.022 times 10 to the 23rd might need to be in parentheses in order to get the correct answer out here. So I'm getting 137 grams. All right, well, how many sig figs though? Always want to check that. Going back up here, I have 2 significant figures because we're looking at just the numbers before that multiplication sign. So I need 2 significant figures here. So the 1 matters, the 3 matters. I look to the number next to it. It is a 7, so I am going to round up. So it's going to be 1,4, but I can't stop there because I can't go from 130 something down to 14. So I need a placeholder for where that 7 was that does not count as a significant figure, and the only number that doesn't count is 0. So 140 grams to 2 significant figures will be the correct answer. All right. Let's try a little more difficult one. We have, let me erase this. I believe I did these ones on the board before we all got quarantined here. So this one here is going to be a new one that I haven't shown on the board yet. So let's see, we're going to convert 15.6 grams of C3H6, and we are going to go to grams of carbon. Okay, so this one's different because notice we have a compound as a whole with carbon and hydrogen in it, and we're going to grams of just carbon. All right, so how the heck are we going to do that? All right, well, in order to do this, what we need to do is, first of all, we need to get in moles, because moles, like I said, is our middle ground. Okay, so I'm going to write my steps up here, and I'm going to have grams of C3H6. And I told you I need to get into moles first. That's our middle ground, moles of C3H6. Okay, now, why do I want to be in moles? Because if I'm in moles, I can compare, I can use the mole ratios. So we talked briefly about mole ratios in class. So to get, if I'm in moles of C3H6, I can use the mole ratio to get 2 moles of just carbon. So let's look quickly at how we're going to do that. So I'm going to write up here that this step is going to be a mole ratio. To figure out the mole ratio, remember, if we have 1 mole of C3H6, we can figure out how many moles of carbon there are present and how many moles of hydrogen that are present, just given the subscripts. So in 1 mole of C3H6, we have 3 moles of carbon, and we have 6 moles of hydrogen. Okay, so this 6 moles of hydrogen, I'm going to erase that because it doesn't matter in this problem, because they're just asking for me to compare it to moles of carbon. Okay, so this right here is my mole ratio. The ratio is 1 to 3. So the coefficients give you the mole ratio. So I'm going to write this mole ratio off to the side because I'm going to use that in this step when I'm doing my railroad tracks. Okay, So the mole ratio that I just figured out is 1 mole C3H6 is going to equal, go ahead and erase the rest of this, 3 moles of carbon. All right, so that will get me in moles of carbon. Am I done? No. What's the question asking for? It's asking for grams of carbon. Okay, so there is one more step. We're going to go from moles of carbon then to grams of carbon. So let's see what we need to complete this. Okay. This step right here, we just said we needed the mole ratio. We have the mole ratio written over here to use when we get to that step. Let's go to these other 2 steps and figure out what we need to use so we have all our information ready when we start our railroad tracks. All right? So looking at this step here, to get from grams to moles, what do we need to use all the time? Grams to moles, we're using, is it molar mass or Avogadro's number? It's going to be molar mass, okay, because molar mass has units of grams per mole, so that will get us between grams and moles. All right, so let's go over to this last step. We have moles of carbon going to grams of carbon. Okay, so once again, we're going between grams and moles, so we are going to need molar mass. So what I want to do now is over here where I have one of my conversion factors already, I'm going to get the other 2. So I'm going to need the molar mass of C3H6. This I'm going to have to calculate, so I'm going to do a quick calculation. I have carbon and hydrogen present, 3 carbons, 6 hydrogens. The molar mass of carbon is 2.01 on the periodic table. The molar mass of hydrogen is 1.008. So let me multiply that across. 36.03 grams. I don't need the units yet. Sorry about that. And then I have 6.048. So add that together. Get out my calculator. 36.03 plus 6.048 gives me 42.08. And the reason I stopped at 2 decimal places is I'm following significant figure rules, and that's grams per mole. Okay, so I'm going to write that up here in a conversion factor form. So what I mean by that is I'm going to take this 42.03 grams, and then that dash sign becomes an equal sign, and on the other side of it I have 1 mole. Okay. So I'm going to go ahead and erase this work here just because I have a limited amount of space, leaving the conversion factor the part I need for when I solve. And then next, got the molar mass of C3H6. So this step, have a conversion factor. The next step's mole ratio. I have that conversion factor here. The last step, I need another molar mass, but this time it's just carbon by itself. Okay. So over here I'm going to write molar mass of carbon. And the molar mass of carbon, just look for it on the periodic table because it's just an element, right? So it's 12.01 grams per mole. So writing it in a conversion factor form, I will put an equal sign separating those. So I have the 3 conversion factors that I need for my 3 steps. So let's start the calculation. Now this is going to be a big railroad track. I hope I have enough room to do it on this board here, so I might have to write a little bit smaller. So I'm starting with what's given in the problem. Okay, so going back to the original problem, 15.6 grams of C3H6. So my first step tells me I'm going to use the molar mass of C3H6 to convert from grams to moles. So I'm looking at this guy here. Okay. Now I'm going to put the grams on the bottom, so the 42.03 grams is going to go on the bottom so that grams cancel. My 1 mole is going to go on the top. Okay, so now I am in moles of C3H6, so I'm here, right? Okay, so my next step is to get to moles of carbon, and in order to do that, I'm going to use a mole ratio. So the mole ratio I have written down over here, saying for every 1 mole of C3H6, I have 3 moles of carbon. So I am going to put 3 moles of carbon on top. Let me add C3H6 here so we're not getting confused. And then on bottom, I'm going to put the 1 mole, because that 1 mole in this conversion factor here, right, is referring to the C3H6, and that's what I'm trying to get rid of, is the moles of C3H6, so that I'm left with moles of just carbon. So moles of C3H6, moles of C3H6 are going to cancel. Now I have my moles of carbon using that mole ratio. The last step now is using the molar mass of carbon. Okay, so moles is going to go on the bottom because that is what I'm trying to get rid of. And they need to be on opposite sides of this line to cancel. So the 1 mole on the bottom, and then my 12.01 grams of carbon on the top. Okay, and we're going to do more problems like this in stoichiometry as well. So this won't be the only one you see. All right, so a lot of stuff there. So let's calculate it out. Remember, we're multiplying across and then dividing by what's on the bottom. So 15.6 multiplied by 3 multiplied by 12.01. And all of that is going to be divided by 42.03. So how many significant figures? Let's go back to the top. So I have 3 significant figures. So I want 3 significant figures in my answer. So I'm going to do 13.4 grams of carbon. Okay, so what this answer is saying is that out of that 15.6 grams of C3H6, 13.4 grams of that is just carbon. And the rest is from the hydrogen, from the mass of the hydrogen. All right. So, let me know if you have any questions or need me to do any other example problems. I will also be posting some videos by other instructors, so hopefully those will help you as well.